the last section of the Seabird notebook, it's about how we can use shapefiles that we already have in our computer to create a map and also a joint with the information that we have in the cloud from the NESP data. So we have provided a compressed folder. So it's the Offshore Renewable Energy Infrastructure Regions.zip. So then you can unzip it. The information how to do that is there. And then we just load it into our system or in our computer. So for this example, we're just going to look at some of the infrastructure, not all of them, just to make things a little bit simpler. So we're going to filter these by the status. We're only going to select the things that have been classified as declared. And then we're just going to select the region and the geometry so we can plot it. And then we're just going to do a bit of renaming, so to tidy up the shapefiles and the information that we're going to use. And then we're going to transform it to the same reference system that we have the Seabird data in, which is WGS84 or EPSC 4326, as you can see here. So that's why we transform it, otherwise it won't plot in the same way. So this is what it looks like after that transformation. So we only have 6 areas, including the Southern Ocean and some areas around Tasmania and the south of Australia. So now we're going to use our df variable, which contains the Seabird data that we access from the cloud. And we're going to just filter using the tags from the Australian Marine Regions column. So we're going to keep anything that is in the southeast or southwest of Australia, as well as the temperate east, which includes all this area, south of Australia, essentially. So because this is a data frame or a table that contains information not only about the coordinates, but a whole bunch of other things like the species of birds that we found, how many of them we found, and many other things, we need to convert this table to a shapefile or an SF object. So we do this by using the SF library. This is the function st_sf. So we provide the coordinates. So we know that the decimal longitude and decimal latitude is where we have the coordinates. So that will be provided in here in this first section. And then we need to make sure that we use the correct reference system, which again is the WGS84 or 4326. So then once we do that, basically it looks the same, but instead of having a 55 columns as initially it did, it will now have 56 because it now includes the geometry as we saw in the previous section. And the geometry column is where we have the information about how we can plot this across the space. So now that we have these SF objects, we can do a join. So this is part of the SF package again. So stjoin just basically puts things together, looking at the reference system. So we provide the data frame that we just filtered here at the top. So anything that is all the points that are south of Australia essentially and the temperate east. And then this is the offshore wind areas, wind or renewable energy infrastructure that we also filter just the declared ones. So then we join those two in here. And then this filtering is basically anything that is not present in both SF objects will be excluded. So that's why I call it overlapping points in here. And then we just plot this using ggplot. g_sf is an easy way of plotting this sort of data. So in here, the orange polygons that you can barely see in some areas, this is where the limits of the infrastructure, renewable infrastructure are. And then I'm just putting the overlapping points based on the tag using the marine classification areas. So then we can see that then we have the Bass Strait of northern Tasmania, as well as some others in here. But then if we want to use the H3 library as we have been using for these examples to create the hexagons, we can do so. We just grab this new SF object that we created with the overlapping polygons and points. We can use the coordinate system, which is stored again in that geometry column, to create those indices for the H3 hexagons. So we don't actually need to provide the location of the geometry because it will automatically identify that. So we just use this geo_2_H3 to do the transformation. We just select the resolution. In this case, we're going to go for 6. And then we are just going to calculate a few other things like we've done before. So we group by the index, we calculate the number of records, we calculate the number of data sets, as well as the actual names of the data sets that we have available in each one of these hexagons. And then we're going to join everything together. And we're going to make sure that we include that references for the H3 or the indices for the H3 in a single column so we can plot this. So we use leaflet once again to create a map that is interactive, and this is the result here. So we're using the same sort of color map that we've used before. So the warm colors again are the ones where we find the most records. So in here we have 35, and the blue ones, they only have a small number of records, or the cooler colors. So in this case, it's just 2 records and 4 records in here. And that's it.